Welcome back to Vuln Vibes. In this deep dive, we're going to talk about the n8n exploit. So today we're zeroing in on a critical remote code execution vulnerability, an RCE. And this one has some pretty major implications for, any operational security teams that are using the n8n workflow automation platform. We're looking specifically at GHSA-WPQC-H9WP-CHMQ,
which maps to CVE-2025-65964.
Exactly. And if you're relying on n8n for, orchestrating sensitive data flows or back-end interactions, which is kind of the whole point of these tools,
Right.
then this is really an analysis of execution path hijacking that you need to get into your risk register, immediately.
Absolutely. And when a flaw gets rated critical, especially in an automation engine that, often sits deep inside the network perimeter, we really need to understand the mechanism of the failure, not just the outcome. And this vulnerability is a fascinating case study in how intended functionality, in this case, configuration management inside a Git workflow, can be abused. It becomes a primitive for command execution. The attacker is basically co-opting the host system's trust in Git to run whatever they want.
Okay, so let's unpack that vector because it's a really neat example of configuration abuse. The component that was the initial beachhead for this RCE is the n8n Git node.
Right, a standard feature.
Yeah, it's bundled in the npm n8n package, and it's just designed to let workflows talk to repos, pulling code, commits, standard DevOps stuff.
And that is precisely where the trust boundary failed. The flaw is specifically within the Git node's functionality that lets you set Git config values. There's an operation called add config.
Okay.
It was meant for benign things like letting users customize their name and email for commits, but it lacked sufficient input sanitation. There was no real whitelist.
So instead of just allowing known safe keys like user.name or something,
Exactly.
it let you inject basically arbitrary key value pairs into the Git environment.
That's a perfect assessment. It's an architectural oversight. They just assume too much trust in the input from the workflow user.
Which seems like a classic failure to really compartmentalize the threat model.
It is. The system trusted the workflow input implicitly, which brings us to the actual execution chain. The exploit isn't some classic shell injection in a text field. It's much more brilliant. It's a redirect.
How so?
The attacker uses that add config function to specifically set one Git variable, and this is the one to remember. core.hooksPath.
Okay. The hooksPath. That's the classic Git mechanism for defining where to look for local executable scripts, right?
Yeah.
For events like pre-commit or post-merge.
You got it. So if an attacker can control that path, they effectively control the entire execution context for any Git operation that follows.
So they're not even injecting the malicious payload directly into n8n.
Not at all.
Yeah.
They leverage the Git node to, say, clone a repository that they control. At the same time, using that add config operation, they point core.hooksPath to a directory inside that malicious repo they just cloned.
And that directory would have a pre-staged script in it, something like pre-commit.
Exactly. A pre-commit or post-checkout file, already executable.
So what happens when the workflow finishes setting that config and then tries to do its next step, like maybe pulling from the repo or committing something?
The game is over at that point.
Right.
Git, just operating as designed, assumes it's a legitimate configuration. It faithfully executes the script it finds at that attacker-defined path. And because Git hooks run as local system commands, usually with the privileges of the user running n8n,
it just bypasses any application-level security and gives you command execution on the host OS.
Full arbitrary command execution. It's an incredibly effective, very low-complexity path injection into a trusted external binary.
That is.
Yeah.
Yeah, that's deeply concerning because when we talk about these automation platforms, their whole execution environment is often privileged. It has to be to talk to internal services and secrets. But before we get into the subsequent impact, let's talk about the barrier to entry. What are the prerequisites here?
Well, this is what makes it so dangerous in, say, an internal enterprise environment. This isn't some 0-day you can just launch from the internet with no credentials.
Okay, so there's some prerequisites.
Yes, but it's a low one. The only thing an attacker needs is the ability to create or modify an n8n workflow that uses the Git node.
So we're just talking about standard low-level user permissions. They don't need admin access to the whole n8n instance.
No admin access needed. And that ties directly into our CVSS analysis later. It's what makes the privilege requirement low. Any authenticated user who can build a workflow is a potential vector.
And for security teams listening who are trying to assess their exposure, What's the affected version range?
It's a big one. This flaw affects all versions of n8n greater than or equal to 0.123.1 and strictly less than version 1.119.2.
Wow, that's a huge operational window. A lot of legacy deployments are probably exposed.
For sure.
Let's pause on the architectural failure. You mentioned it falls under a specific weakness type. Can you elaborate on that? CVE-2025-659?
Yeah, CVE-2025. Inclusion of functionality from untrusted control sphere. For any security architects listening, this really helps define the class of flaw.
So what does that mean in this context?
It basically describes a situation where your system imports or runs executable functionality, in this case, the git hook script, from a source outside of its intended trusted control sphere. The n8n application is supposed to control the workflow execution, but by letting an attacker define core.hooksPath to point inside an untrusted repo, the system is effectively handing over command execution authority to that untrusted source.
I see. So the trust boundary is between the workflow logic and the host OS. And the flaw is that n8n lets the workflow corrupt the configuration of a trusted helper, which is Git.
That's it. Git then does the dirty work on its behalf. It's a classic case of mismanaging an external process execution path.
And it raises immediate questions about process isolation, container security.
Oh, absolutely. Even if n8n is running in a container, if that container doesn't have strict syscall filtering, the RCE you get from the Git binary is very likely to lead to container escape, or at the very least, a full compromise of everything inside that container.
Including any credentials mounted in there.
All of them.
Okay, that context is invaluable. Let's shift to the risk assessment, a critical rating that demands a detailed breakdown of the CVSS v4 metrics.
Agreed. And just giving the vector string isn't enough. We need to explain what each metric really means for your risk posture.
Let's start with exploitability then.
Okay, first up, attack vector AV is network N.
Meaning no local access needed. If the n8n instance is on the network, it's vulnerable.
Correct. Next, attack complexity AC is low L. This is a simple deterministic flaw. No race conditions, no complex crypto, just a straightforward config injection, easy to weaponize.
And attack requirements AT is n8n. This confirms you don't need any unusual circumstances. It works against a default standard configuration.
Which is then compounded by the privileges required, PR being low. As we said, just a standard user who can edit a workflow.
That's the critical piece for internal audits. A single low-level service account could lead to complete host RCE.
And those accounts often hold keys to the kingdom for other services.
Right. And to round out exploitability, user interaction, UI, is none-n.
No one needs to click a link or approve anything. Once the malicious workflow is deployed, it can be triggered by a schedule or an internal event. Fully automated.
Okay, so low privileges, low complexity, network access. That's a recipe for disaster.
It is. And that's just the exploitability side. Now let's pivot to the impact metrics, which is where we really see why it's critical.
Right, and we need to separate the impact on the vulnerable system from the subsequent system.
Exactly.
Let's start with the n8n host itself. What's the maximum fallout there?
So on the vulnerable system, the local impact, the metrics are just maxed out. Confidentiality, integrity, and availability are all high. A successful RCE means total host compromise. An attacker gets full read access VCH to everything, the n8n config, environment variables, any linked credentials.
They can manipulate system files, database states, so that's integrity, high.
Correct, VIH. And of course, they can install backdoors or just wipe the system, so availability is also high, VAH.
But the real terror of hitting an integration platform is what you call the wormhole effect.
That's the most important takeaway for any incident response teams listening. The 8n host becomes an attacker-controlled beathead with high trust access to the internal network.
So the subsequent system impact.
Also all high. Subsequent confidentiality, SC, integrity, SI, and availability, SA are rated high. The RCE grants immediate pivot capability using all the sensitive credentials 8n was entrusted with.
Cloud credentials, database strings, internal API tokens.
All of it. The low privilege required to pop the first box is instantly converted into maximum impact on all connected systems.
It's privilege escalation via systemic trust failure.
Exactly. So for the ops teams that just need the data point, the full CVSS v4 vector string really tells the whole story. It's CVSS,
CVS4.NAC.NE.NVC.NVC.HVI.HSC.HSC. Maximum severity across the board from a low-effort attack.
That's the summary.
Okay, now that we've established just how severe this is, let's talk remediation. What's the definitive patch? Thankfully, the remediation path is clear. The n8n team patched this, and the fix is in n8n version 1.1119.2.
So the recommendation is an immediate upgrade.
It's a mandatory upgrade to 1.111.2 or later for every organization running an affected version. And remember, that's a huge range, anything since version 0.123.1. This isn't technical debt, it's an active incident risk.
For sure. But, in some large enterprises, immediate patching isn't always feasible. Change control, testing.
So are there any workarounds? What can teams do in the meantime?
There are a couple of mitigation strategies. First, if your workflows don't actually use Git, the best thing to do is just disable the Git node functionality entirely if you can.
But if you need it.
Then the second strategy is crucial. You have to enforce a strict operational policy to avoid using the Git node against any untrusted or public repository.
That feels like it relies on perfect policy enforcement, though. If one developer accidentally points the node to a public GitHub repo,
Yeah,
the risk is still there.
it is. This effectively requires you to air gap the threat by guaranteeing that the contents of any repo you clone, the repo that could hold the malicious hook, are absolutely trusted.
So until you're on 1.119.2, any user who can point that Git node at a repo they control is a walking critical RCE risk.
That's the bottom line.
This whole incident is just such a powerful illustration of modern supply chain risk. I mean, the key takeaway isn't just Git hooks are dangerous, we knew that.
Right.
It's that these seemingly harmless internal configuration options, like setting core.hooksPath, could be co-opted to execute code in what is a highly privileged, trusted environment. It's configuration drift becoming command injection.
It forces a reevaluation of trust boundaries in these low-code platforms.
Right.
And given that combination of low privilege required and maximum subsequent impact, it really demands a shift in how we audit these things.
How so?
Well, instead of focusing only on perimeter defense or traditional web app flaws, security teams need to be asking a different question. How frequently are our internal automation platforms the custodians of our most sensitive credentials being rigorously audited for these kinds of execution path injection flaws, the ones that weaponize trusted internal binaries? The vulnerability here wasn't in n8n's own code execution logic. It was in its failure to safely configure an external trusted dependency. And that's the future of supply chain risk we have to prepare for.